So I am here with Kurt Manninen, who is recently a seller on Gravity AI, who's going to tell us a little bit about the model that he created himself and some of the cool use cases that you can use for it. Kurt, thanks for being here.
Yeah, thanks,
Tell us a little bit about yourself.
Sure, yeah. Well, yeah, I'm Kurt Manninen. I'm a data developer, data scientist, and I built a topic similarity model that I'm excited to put on the Gravity platform.
Super cool. I find that field of data science is in extremely high demand right now. Like
Yes.
anything related to, any NLP stuff right now is in just being constantly ingested.
Yes.
And there's some really cool stuff that you can do with topic similarity, which we'll get into in just a moment.
Sure.
But could you tell us a little bit just about the model? What is the model? How did it come about? Why did you start working on it?
Yeah, sure. So this model really came about. I was working with a company called AI1 here in San Diego way back in 2012.
Oh, wow.
And we had a new AI kind of neural net that we were investigating and playing with. And we had a number of different customers that were bringing us problems. And one of the themes that we kept getting was kind of the needle in the haystack problem. A lot of the customers had documents, lots of documents out there that in SharePoint or Dropbox, and they knew they had information there, they just couldn't know how to find it.
Sure.
Their traditional methods might have been doing keyword searches, using their brain, thinking about what's the top keywords for what I'm looking for, and then maybe hiring people just to brute force go open up every document and look for these. So
Painful.
Yeah, it's a lot of work.
That was, and I remember. So everyone hates SharePoint. I remember that, and I think one of the reasons is why is what you just described, right? Stuff just gets buried in there at an enterprise, and it's massive. And if you don't know where something is off the top of your head, it can be impossible to find.
Right, especially if you do, or if you know, I want to do a search for a document that has the word bubblegum in it. And you might get a 1,000 documents that say bubblegum if you're in the bubblegum industry. And now you got to, how do you sort that? How do you start going through and finding that? Sure. So we had an idea. We said, what can we use this model that we have, this AI model? Maybe we had already tested it out with text and identifying keywords and distances between keywords. And we thought, can we come up with a way to what we call come up with an AI fingerprint of a topic.
Very cool.
Train this model to find certain topics.
Yep.
And that's how it started. And that was 2012, and we're still kind of, what's in Gravity right now is kind of the same model we built back then.
It's amazing.
Yeah, it is. Yeah. It's pretty cool.
It's pretty ahead of its time.
It was.
That's rad.
Yeah.
So we went through probably the main use case, right? Mm-hmm. That was the original use case for the topic similarity model, which, by the way, I think is amazingly still a huge problem. Yeah. Sorry to SharePoint developers out there, but I don't know how many of you exist, but there still is this issue of massive amounts of documents that exist in organizations. But I know you and I have talked about some other pretty cool things that you might be able to do with this model. And I think it's one of the things that I've learned from being in Gravity for this long now is that models exist that solve a lot of problems, but we don't always know those various use cases that model could be applied to.
Right.
Companies struggle with this internally too, how do I take a model that was developed in this part of the organization and distribute it and find use cases for it across the organization? So the fact that there are other applicable use cases for this is pretty rad. Do you a few of those off the top of your head?
Yeah, I can think of 3 different use cases. One would be again, the needle in the haystack. We just talked about that one. Maybe prioritizing. I would call it the last mile, like in shipping. You've got terabytes of data, and then for that to get down, you might do a keyword search. You could use Elasticsearch to get down and find the top 1,000 documents of a topic. And then
that's not particularly helpful.
Still not helpful, yeah, especially if you're in a legal domain and if you need to find that document and you're paying people by the hour to read these. So how do we prioritize those? So you could do that for the prioritization. Another example that we came up with was use case, that we've done is labeling, categorizing. So you could train the model to always look for certain fingerprints of a topic. Like bubblegum, I'll go back to, I don't know why this came in my head. But, so maybe you search, so you have a subscription to blogs or news readers, and you just kind of do this, constantly scanning documents, scanning articles, and anytime you see a topic in there that's about this bubblegum or whatever, you can flag it. And then model it or put it into a visualization, and maybe add tags to it, and you can run this concurrently in parallel with lots of other fingerprints at the same time.
I actually know like a lot of software companies who are trying to ingest an enormous amount of content. One of them is actually our customer that we're working with, who ingests a lot of travel content that we've done some use case stuff with before. And this is a pervasive thing with these different companies who ingest massive amounts of text from either their customers or from other places online and are trying to classify it. Many of them doing that manually today, which is thousands of dollars. But it sounds like with the topic similarity model as part of a broader pipeline, they could automate a huge chunk of that, potentially saving those thousands of dollars. Is that fair to say?
Yeah, totally. They could save models of every concept or category that they're interested in, topic, save that fingerprint or the training piece of it, and just have a catalog of, this is trained on this topic A, and this is topic B, C, D, and as their pipeline is gathering data, documents going through the pipeline, just flag it. Oh, this document has topic A in it. This document has topic A and C in it. Some other kind of industries that could use this might be like doctor's notes. And going through and tagging doctors' notes that they write. They're making notes of their patients or whatever. Of course, legal documents, legal discovery. And maybe surveys, or even like trouble ticketing systems where people are writing in issues for things, and they can just kind of automatically tag them.
Very cool.
Yeah.
I know specifically, I've heard of use cases for in legal where they were looking at not just the research for like trying to dig in for case law and other things, but they're looking at things like individual cases themselves and what were those outcomes, and they might be able to kind of classify some of the outcomes that came from those, which is pretty cool. I've seen a lot of this too, like on the process automation side, when we talk about like doctor's notes and other things that are very time consuming, you see that a lot with like contracts or very repetitive types of forms, as there were stuff that you can pull out of there as well. And the famously, like JP Morgan saved hundreds of thousands of man hours with like this type of thing in a broader pipeline of automation.
Even just looking through like terms and conditions, TNC documents.
That's a great
documents
example.
might be a good one, making sure you have the correct clauses are in these documents as they're coming through. It works really well for documents that are unstructured paragraph level text. I'm not talking about tweets or sparse vernacular things, more like well written or even like medical journals and academic journals.
Super
really
cool.
For that.
That's awesome.
Yeah, it's cool.
Very cool. Oh, you know what? Another one that just came to mind was I have a friend in the entrepreneurial world who's building an ed tech company. And he wants to help students locate topics within textbooks so that they don't have to dig through stuff.
Oh, that's exactly like that.
That's a great use case. I'm going to have to connect you guys.
Please do. That'd be great.
Awesome. And I think we talked about beyond that, was there like a third use case?
The third one is more like visualizations. Being able to, you can use these similarity scores are coming back on your chunks of text, and now you have a numerical value for whatever you're analyzing. So maybe you can use that for graphical visualizations, adding some numerical data, associating a number to text.
That's super interesting. Now, I only know slightly about this type of space, so please correct me if I'm wrong, but I remember I worked on something called Word2Vec a long time ago, which creates, recognizes distance between words and bodies of research and assigns like a distance score to that. Is that similar to what we're talking about here?
Very similar. In fact, it's actually kind of buried, Word2Vec's buried in here.
Oh, cool, yeah.
So we do a similar kind of distance score, amongst other things in the model. So this distance score, or this is bundled into the similarity score that the model brings back, and you can use that just kind of even just plotting values. You have 1,000 documents, and being able to see a graph of it, and you can start seeing outliers. Why does this document have such a high score compared to the other ones? Or low score, and just maybe just for discovery, for investigation.
When we were using Word2Vec, we actually were using it to try to uncover interesting connections between words and financial news. With the goal of trying to understand like what things might be more related to each other than others. Like, could we uncover interesting like hidden connections between equities or something that had a pervasive amount of mentions together in the news that someone might miss. It sounds like with the type of scoring that you guys are doing, like something like that would be possible as well for kind of analysis purposes.
Totally. In fact, you mentioned that we're another company that was using this model, kind of a spin-off of AI1, was analyzing earnings calls, transcripts from earnings calls, and finding topics. So like anytime they were looking for topics that might be mentioned. So are these in this earning call? Do they talk about the oil industry at all?
Right.
It might be Google or some earnings call, but for whatever reason they're talking about oil industry. So like just kind of constantly listening on these calls, or scanning the transcripts and looking for topics.
Super cool. Like, one individual could probably read one earnings call transcript, right? But they're pretty big. But like when you're talking about trying to find trends in these, it would be very difficult for someone to go through all the earning call transcripts and like dig out what topics were discussed.
Totally.
And so this is a perfect example of like where data science can take in more data than we are capable of ingesting and finding those trends.
And just help you. You're not programming it to find data. It's just helping you to help you cut down the amount.
Right. We sometimes call it augmented intelligence. So we mentioned Word2Vec already as being like one of the components that went into this model. But could you talk a little bit about how this was built? How did you actually create this model?
So basically this model is built on top of a number of Python machine learning libraries and language libraries. Word2Vec is one for counting distances. We use scikit-learn for some analysis, and NumPy for some of the numerical things. And really the goal is we're trying to make something that's easy for end users to use. Engineers don't have to think about how to program a model, and definitely don't have to do these if-then cases with keywords. Basically, the model takes 3 inputs. One is a topic that you're looking for, and the topic could be, you have a document here, for example, and you just copy and paste. Let's say this paragraph here might have the needle that you're looking for in the haystack. Just select it, paste it in as an example of what you're looking for, and then you have this. That's one input. That's the topic, and the second input would be the data that you're training. You need to train the model on, kind of the background data. And again, the background data. If you're going to search against medical journals or financial statements, you want to have that in the background, as opposed to training it against tweets or news articles or blog entries.
Stuff that's related to
related, so the model kind of understands what it's looking for and knows how to read it. And finally, your third input is just an array of documents that you're looking at, your unknowns. You put those 3 in, and the result will be that same array of unknown documents, and each one of them will have a score of how similar it is to that topic, and then you can sort that and start
That's
start
awesome.
looking.
That's super cool. I love what you've done here, because there's this whole movement right now of how do we get these types of models into the hands of engineers or the rest of the organization that might not have like direct access to like deep data science talent or know Python in this case. And you've made it super easy to like go to Gravity AI, download that model, put your inputs in, train that up, and now you've got your topic similarity model ready to go in a pretty easy way. Is that fair to say?
Totally fair. That's why Gravity is pretty such an awesome place to market. Yeah.
That's awesome. Yeah, I love that. So if someone wanted to use that, like the Gravity AI container, I think you've described the inputs here, but you know, we try to make everything with that standardized set of API endpoints. So those inputs would be part of those endpoints, and then what does a typical output look like?
The output's usually right now it's like a JSON JavaScript objects of, again, just a list, an array of document ID and score. There's the original document IDs that came in, and an array, a list of scores.
Super cool.
Yeah.
Then you use that score to dig through, find that needle in the haystack of your other documents. I think that's great.
Yeah.
Kurt, I knew a little bit about your topic similarity model, obviously, because we list it and we've chatted before, but talking through all these use cases now, it's like even more exciting, like what you've created here. So thanks for walking us through it, man. I appreciate it.
This is great.
Pleasure, man.
Thank you very much.
You bet. Cheers.
Cheers.